Following the explanations of examples on how to use equations for ideal transformers, we are going to do this example together. So we are going to look at this example which says a transformer has 30 turns in its primary coil and 6 turns in its secondary coil. The input should be input here. So the input voltage is 100 volts. Now, before we start calculations, I want to ask you a question. Is this a step down transformer or a step up transformer? So the answer to your question comes back here. You need to understand the statement. So in the primary coil, primary number of turns. So number of turns in the primary coil is equal to 30, right? Now, in the secondary coil, the number of turns is equal to 60 turns. These are turns. Remember, they have used the term turns. Even here, when numbering, we use the term turns. We don't need to use other terms here. So it's turns. Now, away from this one, we have been given the voltage. When you talked about the input voltage is the AC supply connected to the primary coil. So this is the voltage in the primary coil, which is equal to, this is 100 volts, right? Now, if we talk about calculate the output voltage meaning the voltage in the secondary coil, which is a question mark. So it is from there we can come up now to do some calculations. So what we are going to do, we are going to write the formula. Number of turns in the secondary over number of turns in the primary, which is equal to the voltage in the secondary over the voltage in the primary. So if you write this equation, it becomes very easy for you, just replacing the figures or substituting them. So what we are going to do is to just get the figures there. So we have 60 turns over 30 turns, okay, which is equal to voltage in the secondary, we do not know it, and then the primary voltage in the primary, that is 100 volts. So from there you can just multiply these two, and then you will have 60,000 turns, or if you want, let me just write them all. Turns, then you have watts, turns, you have watts there, then which is equal to, if you multiply them, you will have 30 turns, then watts, secondary watts. So we can divide both sides by 30. So we're going to divide both sides by 30 and this side by 30 turns. Okay? So cancelled, we have just remained with VS, which is voltage in the secondary, and then we can state how many times can 30 go into 60, that is 2. So meaning that, and turns, and this 10 has gone. So what you have remained with is 200 volts. So meaning that the output voltage is 200 volts. I hope you are following. When we come to if the current in the secondary coil is 4 amps, determine the current in the primary coil. So in this case, what we are going to do again here is very, very simple. So you write the formula, say current in the secondary over current in the primary, which is equal to, okay, current in the secondary primary, should be primary here, sorry. Current in the primary over current in the secondary, which is equal to voltage in the secondary over voltage in the primary. It's the opposite of what we have done here. This one normally confuses a lot of people, so we need to make sure that you practice, you master it properly by practicing a lot of questions. So from there we can now substitute. We are using the same data here. Remember, I encourage my students to make sure that they they come up with the data before they even start calculations. And again, you need to make sure that you master the formulas and you practice them. Once you do that, calculations in physics are going to be superb for you, are going to be very easy for you to solve. So current in the primary, let's check. This is the current in the secondary. Current in the primary, we do not have it, so we are going to say current in the primary, we do not have it, over current in the secondary, which is 4 amps. Okay, right? This is equal to voltage in the secondary, we have it, which is a 200 volts, and then voltage in the primary, we have it as 100. So we have the voltage there as 100 volts. Okay. Now, away from this one, if you want, you can now go there, substitute by subtracting, multiplying. So you have 100 volts in the times, just hold on, 100 volts. Okay, this is the number, and then we will get this one, we put it down there. It's going to be current P, which is equal to 4 times 200, that is going to be 800. That is 800 volts. Then we have here, amps. This is for the F. Then from there, what we are going to do is to divide 100 on both sides, 100 volts on both sides, because what we want to have is to find the current in the primary coil. So the current in the primary coil, the current, so in this regard you can write it here, say, okay, current in the primary coil is equal to, so when you divide 100 into 800 volts, the answer you have is 8 amps. So this is the current in the primary coil. Now, I want to challenge you, those who are watching this video for the first time, make sure you subscribe to Science Corner TV and also start following us on the page Science Corner, Facebook page Science Corner TV. Thank you very much for watching. Remember to subscribe and also to share to as many people as possible so that they can also acquire the same knowledge you have had. Now, I'm going to leave you with a question. The question is going to be this one on the picture. It's a multiple choice question. So you have to try it. And remember to give me a feedback by writing the answers. As for now, bye-bye. Until next time in the next video.